Facem test. 2-10, 2-10, test, test, test. 2-10. 2-10, test, test, test. 2-10. Test. Good.
mai să spui microfonul când termin la o pauză 10-15 minute, continuăm cu Costin și după aceea cu Beda.
Stai. Înseamnă că nu se respectă, că agenda era că...
E ok, oricum. Noi încercăm să fim
Al doilea, al doilea. Deci aveam.
Hello, hello. Hello, 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 hello. Vorbesc. Hello. Hello, vorbesc. Vorbesc. 210, hello. 210.
Really happy to have you all here. We are at the second edition of Applied Data in Bucharest, and I'm really thrilled to do quarterly, that we plan to do quarterly this event, and we are happy that we managed to do the second edition, and with all the effort to bring the guests, to think about subjects, to do all the required preparations and so on. And this event, like also the other one, we have 3 speakers. We thought to divide it into 3 sections, 30 minutes each one. We will have, each speech will be 20 minutes, the speech, with 10 minutes the questions, but each speaker will have the stage for its own, and then he will create the flow he wants. However, we still have 5 minutes between the speeches, time to do a bit stretching, drink some water, drink something else, I don't know. I think, did you try already the food?
Yes.
Okay, good. So the main task is to end the food till the end of the event. I think we can manage that. I shouldn't worry about it. Okay. So, what else I want to say? Everything is recorded here. We will do some pictures. If you don't want to appear in the pictures, then just go and tell to the person who is doing the photographs, and we will take care of that. And also, it's live, so people can see us right now. And also, as I said, recording. If you miss something, you want to see it later again, you have the recordings. Now, let's go to the event. Let's start it. We have the first guest. It's Bogdan Beda, who is a principal software engineer at Microsoft, and he's working for Copilot. Who tried, tested Copilot? Okay, perfect. So.
Depends on which Copilot, because we are very good at messing names up. So.
That's it's your stage. You will explain us, but the questions are you have here the possibility to write a lot of questions, and Bogdan, he's let's say he's passionate about quality, about coding, and the thing he will bring here, the challenge he will be here is like, what does a person like him do right now when Copilot and AI generally is doing a lot of coding, and then what can he do right now? Yes, and I will let you on the stage to guide us in the next half an hour to the subject. So welcome, Bogdan.
Thank you. All good with the sound, everything? Okay, so thank you for being here. Thank you for inviting me. Thank you for the introduction. I indeed work for Microsoft and Copilot, but not GitHub Copilot, so not the developer tools, but the Copilot from M365, so the one you see in Teams, everywhere else. Like I suppose I've seen you are using Teams, so I suppose you have M365 in the company, so you are using that. And I'm mostly responsible for the people integration, so which is right now is not the greatest of integrations, but that's why we are there. I only moved in that area in the past 2 months, so 2 months ago, 1st of March. We are just trying to make sure that Copilot answers pretty good answers and has grounded answers in your enterprise data and resolving people hierarchies and discovering skills, knowledge, and stuff like that in the organization. But I'm not going to talk about that today. I want to talk a bit about what we do or how we use AI, because Microsoft has been, as you probably know, trying to lead the AI wave even since the beginning with the open AI investments and trying to be at the forefront of the change in there. And even since the beginning, our culture shifted a lot from trying to do things without AI, basically doing everything with AI. As you see, Copilot is everywhere, and this is why I said that I think we messed up a bit the names, because we call Copilot everything, but there are different things to that. However, the internal culture is so that The first option you have, you use AI, whatever. If it doesn't work, try to fix it and get back at using AI and keep iterating on that. So since the beginning, I used AI for all kinds of things and all kinds of different ways. But at the end of the day, we need to be productive, right? So it's not like, yeah, we can experiment, and we are constantly experimenting as a team, as a group, with all kinds of things. We are actually using both GitHub Copilot and Claude, so it's not like they are competition and we are not going to touch them, but it's the opposite. Let's use that as well, see how it works, and get feedback to our team so that they can also improve in that sense. Just compare them and so on, and do the best with all the tools available. So I have tried a lot of things, but I feel like right now we kind of settled, or personally I try to understand what is the best thing I can do to actually deliver something, whilst also trying to experiment. So the presentation today is not about, I don't know, fancy workflows and all kinds of, I don't know, I start something now, go on holiday, come back in a week, and the whole Copilot thing is basically implemented. I haven't seen that yet, so I know I've seen on the internet, LinkedIn and so on, there are a lot of stories like, oh, I built this project without, I don't know, doing anything. I just told it, build me whatever, and then I make a lot of money. That didn't work for me, at least up to this point. I have pet projects at home. I work with these things for Microsoft, but didn't manage to get everything done just by clapping my hands or just saying a few words. So the presentation is going to be focused on what we need to do to take advantage of this and to actually become more productive and use them, whilst also staying in control. Because from what I've seen, again, in practice, once we start generating a ton of stuff, how do we actually validate that that ton of stuff actually makes sense, is working, it's easy to maintain, somebody else themselves or their agent can make sense of what was built in there. And in here are some of the things, like probably we constantly hear, like we are doing vibe coding. A lot of people are doing vibe coding. Everybody can do vibe coding and build all kinds of crazy things. The code is cheap, right? So code doesn't matter anymore. You just throw things at the agent, output some code, all very cheap, just the cost of tokens, all great. All sorts of crazy agentic workflows that work for weeks or days or whatever and resolve everything. And then one that is very interesting is the fact that AI is replacing engineers. How many of you are afraid of that? Are we going to be replaced? I think we are going to be replaced in the way we are doing engineering now, right? So the things we are doing, the things we used to do are going to be replaced, but that's not something new. I feel like throughout the years, so I've been in the industry for 15 years or something like that, things have changed since 2010 until now, and even before it was different, right? So 20 years ago, you were valued by writing a lot of code. Fast forward 10 years, you are valued by integrating different APIs together, then being able to use some services. You don't write all the services from scratch. You don't write the queues. You don't write the storage and so on. You just go to the cloud and know how to combine them together, build infrastructure and so on. And now we're at this stage where all of that is mostly done by AI. The code is generated, but we need to know exactly what we want, and we need to be able to properly validate that. And one thing that is very close to this, and I feel like it has a lot of hype, and I've tried it myself and I'm still trying at it, is this idea of specs to code. How many of you have written a spec or received a spec or something, I don't know, did it, refined it and so on, gave it to the agent and got something out of that?
Only for the tokens.
Okay, how many of you were happy with the output of what it produced? What did you do? Like what? Can you give an example?
Small projects in .NET.
Small projects in .NET. Anybody with a production feature, things that were shipped to the customer, like a full product? Yes, that's the thing. This works really well for small projects, pet projects, proof of concepts, and things like this. So there is this idea that you write the spec, you get the code, everything works fine. However, when you check it, the first time you open it, you are, wow, so nice. I have this nice UI, this nice styling. You click two buttons, all they work. Once you start using it more, you start finding issues, right? The things were not completely followed, or you uncovered gaps in your specs. Or if you go to the code, you notice that the code is totally like, I don't know, weird hard codings, bad modules, bad interfaces, and all that. And then you go and say, oh, fine, I'm going to update the specs, fix the things I found, and try again. You try again, and it gets probably worse. And then you try again, and it gets even worse, and so on. Because as the context grows, it's very hard to keep track of the big thing you are trying to build. And we hope that by doing these specs to code, we solve the problem, because most probably we think that the code was the problem. So we have the spec, we have the code, and we say, well, great. We do the spec, and we solve the problem, which is the code. But in my experience, the problem is actually the spec. So that's where the whole thing starts. So in my experience so far, the biggest, I don't know, tensions, issues, delays, and so on, didn't come necessarily from how the code was executed. That can also be the case. But most often comes from how the specs were written, how the specs were understood, the gap in those specs, the mismatch of in the language between the engineering, the product, the business. And it's not to say that it's the problem of the product or the business for not specifying things correctly. It's the fact that there is a language gap and there is a difference between these two domains. And in the end, if you try to do everything at once, this is the old waterfall method, where you build something, you plan everything for the next 2 years, you start working, and then after 2 years, 1 year, whatever, you find out that, oh, we asked for something and we came up with something else, right? So it's this idea that you plan everything from the beginning, and then you hope that at the end you'll get the right thing. The problem is that nobody really knows up front what they want. So when the requirements are vague, that's when the engineering starts. You have to actually work on improving those requirements. And then another tension I have seen is this, that usually when business product comes to engineering, they have an idea or a requirement or something. They come and say, we need to do this. Everybody agrees. We estimate, oh, it's taking 2 months. Why so long? Like, this seems easy. It's very easy, right? So why is it taking so long? Now this is getting even funnier, because on top of that, we have the PM, the managers, the business in general, which comes and says, why so long? I've done it. Look, it's working. I've done it. It's just take that and put it into the product. It's done. Why 1 month? Why 2 months? And so on. And this is the trap of the one-shot experiment. And this is where things work great for MVPs, and they are definitely great. And it's great that product people, business people, and everybody else can do these things, and they can actually play with them and experiment and visualize and try out new ideas and so on. But there is a difference between doing all these kinds of experiments and MVPs and stuff, and putting them into production. Because when you put them into production, you hit this big enterprise wall where it has to integrate into existing code. There is legacy stuff in there. There are all kinds of things that it needs to pass. There is governance, security, and all kinds of other things you need to account for. And there is a bigger architecture you need to account for, evolve, maintain, and so on. So we end up by just doing things blindly and using all the agents and generating more code, by generating even more technical debt. And the way to generate technical debt is to write code, right? So if you have no code, you have no technical debt. If you write more code on top of that technical debt, you create more technical debt, and so on. And that eventually gets really expensive. Of course, we can go back, refactor, and so on. But again, the more it grows, the harder and the bigger the cost is to fix that. And the issue with that, and is the issue we actually have in practice, because I would say one of the, let's say, problems we have with Copilot and in companies like Microsoft compared to Anthropic and the others is the fact that they are starting from scratch, so they have nothing else to maintain, whereas bigger companies like Microsoft and all the existing ones, Apple, you've seen how hard for them to integrate in the existing ecosystem. You have to deal with all that legacy. So you have to build on top of that. The things are different. And if you have the technical depth, that's only going to be amplified. And then also another problem is that we use all these things, and we've done this a lot where I work. Something breaks, there is an incident, there is an issue, who's accountable? Well, Copilot. That doesn't work, right? So you need to find ways to remain accountable, although you generate all the code, you do everything with the agent. At the end of the day, you are still accountable, and this, at least for us, this excuse that I generated the code or whatever, I didn't pay attention and so on, it's not good enough, right? So you do that once, twice, 3 times, then your reviews are gonna start to become negative, right? So taking this into account, what do we actually do and what I'm actually doing? So I'm seeing this as taking the process, which we already know as a software industry and have developed over the years, things we are kind of good at already, and instead of replacing the whole process and everything we learned, we just try to amplify that by using the tools into the right place while trying to remain in control and focus on the important things. So we remove the part of, we use the agents to generate the code, to do the implementations, but it's really important for us to get back to the fundamentals of software engineering, use all the learnings we've done so far, all the things we learned so far, and apply them in the process. So if we break down, like for myself, if I break down the process of addressing something new, implementing a new task, feature, or whatever, because we are mostly talking about not starting something from scratch. Most of us, most of the time, we start something once and then iterate over it, right? So it's not like every day you start from scratch. You start once and then for a while, you keep working on something and improve. So when there is a new task, change, anything that we need to implement, I go back to the fundamentals and to the process that I think helped me grow, develop, and have some sort of impact in the places I've been so far, right? So it comes down to getting that task and not thinking about, oh, I have a task, I just go and write the code. If I do that and just write the code, I don't have to do anything because the code can be written, right? So it starts with design. How do I design? How do I understand those requirements, the task? What do I do? What's the architecture? Then how do I break down the work? How do I iterate in that work? And how do I validate what I did? So on the design part, how do I actually use the agents to go through this phase? And this is really nice and exciting because whilst understanding and trying to understand those requirements, you can actually use Copilot, any agent, whatever. I'm just going to use Copilot, but whatever agent works, to try to uncover things into those requirements, right? Try to ask questions and scrutinize those requirements, what you would normally do. So normally when you get requirements, you start thinking, oh, what is this? Why am I doing it? What are the edge cases? How does this work? What the users expect, and so on. That takes time. Now, you can also do that, but doing it much faster by using an agent and start asking the questions and trying to understand what's in there and what can you do and so on by using the agent. Then once those requirements are understood and you understand what you need to do, maybe ask some questions, clarify with the stakeholders and so on. Based on those clarifications, I go and say, okay, how can this be implemented? And again, without AI, ideally you just go and probably you would expect this from some more senior people to go and analyze the code, analyze the architecture, design something, come up with some diagrams, explain how things are done, do some decisions and so on. But now everybody can do this. I can go into an existing code base, I can explore that code base, I can ask the agent to go and do a POC, analyze different options, how I can do this thing I want to change, what are the things I need to change, why change them in this way versus the other, and so on. And when I say this, I'm talking about code bases that they are so large. So for example, I'm working in a project in a solution that has almost 500 projects maintained by a ton of people. And that's only one project. And our work actually spawns across 3 such services, right? Each one has hundreds of projects. And discovering all those, like I'm thinking if I didn't have these, it would have taken me days and days to actually make sure that I understand exactly all the flows, I know where all the changes should be made, and so on. But instead, I go and point the agent to the code base and start scrutinizing. So it's not like, tell me how it's done. But I'm just asking the same questions I would ask myself if I had to do it manually. So where is that? What is important? What is not important? What am I missing? Explain me this flow, look at that flow, and so on. So try to have like that scrutiny and the right thinking, but instead of doing it manually, that can easily be automated by the agent. Also using it as an adversarial actor. So challenge you on, oh, I'm thinking this is the plan. How does this plan fit? How does this work? What are the upsides, downsides? What do I break? Why is it bad? So I have this tendency to ask, if I come up with a plan and so on, I ask the agent, why is this a bad idea? Why is this a bad idea? Like, what can go wrong from here, right? And most of the time it comes with different answers. Sometimes it just hallucinates stuff, so not all the things may apply in there, right? But by just giving those, it makes you think about, oh, I didn't think about this, and you can actually take a decision. As I said, you can experiment quickly with new things, do POCs, and make sure that things work in there. And then after that, consolidate the findings and define the plan and come up with a decision. In this process, the things we know from all the learnings in the industry still stand. Like the architecture is important, the clear separation of concerns, the modules definition, the clear interfaces, change management. One of the most important, in my opinion, things in architecture and system design is the change management, so that when you design something, how does that handle change? Because change will come, right? So it's not like I'm designing this now, I build a strong architecture, but the next week when the business says, oh, we have a new use case. Oh, I have to change the whole architecture because guess what? It was so good that it cannot be changed. So for me, I think this is one of the most important things. How do you combine things and create the components and the modules so that you are ready for the change as soon as you ship the code, right? Because that will easily come. So these things are important. And usually, if you do specs to code, they are not going to be given to you by the agent directly. You have to, in my experience at least, you have to look at them and kind of control them yourself, like have a clear guidance about how these things happen. Then once you do that, you break down. So we have this bigger plan. And you go and, just like with the specs, now there are good specs because we did all that. We give them to the agent and things are not going to work, right? So we need to break down. We've done sprints and agile for 25 years, 30 years almost, 25 years, because of the exact same reasons, right? If we start to do a big thing from the beginning, it's very hard to keep up with all the things, with all the cognitive load. It's very hard to adapt to changes because we don't know what we want from the beginning. We realize later that, oh, we might change things. So it's important to break things down in smaller chunks and try to build them iteratively, test them iteratively, validate them, and so on. And I think this is another important skill we should have as software engineers, this ability to break down things in smaller chunks, iterate on them, test them, and validate them independently so that when you put them all together, they work. And this is also important for the agent because, you know, agents have, or models have a context length. And the more you fill in that context length, the worse results you get, right? Because every time all the context is fed back into the model, and it has to reason about a larger context, and it's very easy to miss details from those. If you start iterating over smaller tasks and validate them independently, your chance of actually getting the right output from the model increases quite a lot. Then we have all this, and we need to validate the outputs. On the validation, of course, we have the old things which still work, like linters, code checkers, static analysis, and all that. And these are all great. I think this can still save a lot of tokens. You don't want to just point your agent and say, oh, fix all my semicolons in JavaScript code or whatever, remove all the empty spaces and stuff like that. So that's fine. We still need to use that. But we also have unit tests, end-to-end tests, and so on. One thing that I've seen happening is, as part of this breakdown and implementing the tasks, we go and say, implement the task and define the unit and create the unit tests. What happens then is the agent writes the code, whatever it does, whatever it has to implement, and then it creates the tests based on the implementation. I've seen this happening in practice quite often, where the tests were actually validating the bad implementation done by the agent previously, right? So I created an implementation, it was not good. I have the tests, now they validate and they confirm that what I've implemented is actually bad. So 2 ways of avoiding that is, one, go back to the old TDD. So first, create the tests based on the spec, validate the tests, review them, and make sure they are sound. And then use a different session, a different agent to do the implementation and to make sure that the tests are not changed, only focus on the implementation. Or try to isolate the two and specifically create an agent or skill or whatever, and to specifically mention that should start from the tests and do the implementation without trying to change the tests. I had an instance in the past where the agent was so keen on doing the implementation, it ended up hard-coding the answers just to match whatever it needed to do. So it had a bunch of ifs. If input is A, then match the output, and so on. And then at the end, did some bunch of bad logic, which was totally crap. So it was not working, but for the inputs I gave, it was great. And then there are PR reviews. I'm not sure how many of you, what do you think about PR reviews? But I think it goes back to the fact that we are still accountable. And what I've also seen in practice is that people tend to use agents to do PR reviews. So what happens is I generate the code, I use agents to generate the code, I use agents to review the code, I give it to you, you use the agents to review, and we are done. And then something breaks, we just look at each other and it's like, oh, you approved it. Yes, but I thought you also used the right tools and did the right thing, and so on. So again, coming back to what makes a good software engineer and what you are looking at in the PR reviews is trying to find out and focus on the important stuff, right? So when you look at the PR, don't just look at, spaces, code styling, all the nitpicks that everybody likes to comment on. But try to fully understand what's the purpose, how does that make the code better than what it was before, if it's on point, if it matches the specs, and so on. And this, of course, can be done manually, as we always did, but it can be done with agents. So instead of having an agent which says, go and review this and whatever, say what you want about it, I have a skill which goes and scrutinizes that code. So it basically asks, why is this good? Back to what I said in the design. Why is this good? Why is this bad? Why is this a good idea or a bad idea? What are other options? Is this the best option from whatever options may be out there? And so on. And how I usually do this is basically use 3 separate models with an orchestrator and say, go and review this code base with all these three, at the end merge them together and explain what were the findings, why did you find them, and what could be a potential fix. And that's because at the end of the day, we are still accountable. And most of the time, I also go and look at the code myself just to, I don't know, have some comfort that I did that as well. So I think we are close to the end here. What I want to remain from this presentation, the main message is that although we are moving at the speed of light and we have a lot of tools and a lot of exciting things coming and a lot of change, all the old fundamentals of software engineering still matter, and I think are more important than ever. That's because technical spec writing, if you don't know how to do that and you write bad specs, there's no way you can get good outputs from that, right? And you can use AI to improve that technical spec writing. If you have a bad system design, bad code, a lot of technical debt, spaghetti code, and so on, when you put AI into that, it's gonna get even worse and things are not gonna work. If you don't manage the tasks correctly and you give a big chunk of things to be done from one go, it's not gonna work right. How do you communicate with the agents? This is also an important skill. Like if you are talking to your colleagues and they don't have no idea what you're saying, if you talk to the agent in the same way, it's gonna be the same, right? So clarity, communication skills, how you are able to focus on the important stuff and explain things clearly. They work with the agents as well as they work with the other humans. How do you scrutinize a system and how your ability to read and understand code in the code reviews and looking at the important stuff. So what does this mean for us? I think that for junior engineers, this is great. So they say that junior engineers are going to be replaced first. But that's going to be a problem because if we replace junior engineers, there will be no more senior engineers to get to that level because there are no more junior engineers to start with. So I think as a junior engineer, this is a great opportunity because, as I said earlier, it shifts this idea that design and thinking and all the planning and so on, it's only for the more senior people, the architects and so on. Now, as a junior engineer, I can use all these tools to tap into whatever, like build diagrams, explore the system, experiment with stuff, create architecture, make sure that that architecture is good enough, and so on. Do proper code reviews or understand better how to do code reviews and so on, use these tools. And as a senior engineer, this is great because you can actually deliver a lot more by just applying the process which took you to become a senior engineer, lead, architect, whatever. In order to get there, you actually have these skills already built in, I suppose. You learn them already. And just using AI and the tools will just amplify this and will let you deliver a lot more faster and with better quality. And yeah, that's it. Thank you very much for listening. Yeah, if you have questions.
So if you have questions, I will give you this microphone and you will speak to the microphone so that the people who are live or who will see the recording later on to be able to hear. So, questions?
Hey, nice presentation, by the way. I really appreciate that we share the same feelings sometimes. So it's nice to have this. So my question is around the PR reviews. While doing this, let's say, iterative work with 3 agents and 1 orchestrator, don't you feel like you are going in some sort of loop? Yes. That you never find the right answer because as long as you whip the agent, it will give you some sort of idea or another idea.
Yeah,
or a
that's
better
actually
or worse idea.
That's actually a good point, and you said that we are thinking in a similar way. I missed to mention that. That's actually what happens. So in this process, you can actually build a loop where you say, you may ask yourself, oh, now I have this agent which does the PRs. I can create a loop and say, just run the PR process until you find nothing. If you do that, the problem is it will find things forever and it will start going back in circles, because at some point it will just say, oh, actually, we need to make this change because of reasons, and we'll go back to point number 1, so where it started from. And we'll just continue to do like that. I actually tried this. And yes, you are right. I think, again, what's important there and why I think this is hard to automate is the fact that when I read that summary in there, I kind of know, like I take a decision that this is good enough. So it's similar like when you do PR reviews in general, you may leave a lot of comments if you wanted to, like you can start just changing things because things can work in a lot of different ways, right? So I can look at something and you may have an idea, I may have an idea, they are different, they end to the same result, but yeah, yours is better because it's yours. So at some point you have to use your judgment and your skills to say that this is good enough and we can move on. So this is what I do. I do that for once, twice, I look at those and then it's like, that's enough. So, or I only tell it to apply the things because I explicitly mentioned that the recommendation should be numbered so I can identify them, and when the fixes are applied, I only apply the fixes that I'm interested in. And usually in 2-3 loops, that's enough. So yeah. And also I use a system where I classify them, try to classify them in high, medium, or critical, high, medium, and low. And it does a pretty good job. So usually the high and the critical and high are quite okay, and I tend to look at those. All the others, yeah, I tend to skip them because, yeah, are just small improvements.
Okay, thank you.
More questions?
What was your biggest challenge in using the AI technologies? The LLM ones, of course.
Yeah. The biggest challenge was I think it's great when you use AI in code bases that you know and you understand, and that works pretty well. A big challenge was when I made the switch and everybody else was already using AI and they knew what they were doing. And I was trying to keep up without knowing what I'm doing, because it's pretty hard to distinguish between good or bad when you don't know what's in there, right? So you do all this exploration. It says all kinds of things. And the question is, do you trust? How much do you trust what it says or not, right? Because I've been, for example, in meetings and decision-making position about this new code base, where I had to rely on the answers from the LLM. So the challenge is when you get this big summary of how things are, how much do you trust them? And this is interesting because I think it leads back to the human interaction. Usually, like if I were to work with a team, probably I wouldn't know all the things in there either way, so you still have to trust that person. The difference is, with that person, like, you can establish a level of trust because you know them, you've seen them, and so on. But with AI, it's non-deterministic and a bit random. So I think this is so far the biggest challenge, and I'm still trying to learn to, evaluate the answers properly.
Yep. Thanks.
Questions? I have one question. So I'm on the vibe coding level. So I'm explaining what I want. Sometimes I get some results and then I modify and so on. But sometimes I come to a point where I think I gave too many explanations, too many instructions, and the output, it's a mess. Is there a way to somehow go some steps back? What would you do in this situation when you try to explain and then you are in a loop? You cannot get out anymore. You don't get the result.
Yeah, so usually first of all, it depends on how you are organizing the things. When I had this, I usually change the model or the system So for example, I had situations where, yes, I was trying like with Copilot or with Claude, doesn't matter, with Copilot or with the specific model, was trying with Opus 4.6 to do something and was iterating and most of the time was coming back to the same place, right? As soon as I switched the model to something else, it was naturally going on a different path. So on a practical side, this is what I've done when I hit this kind of iteration, and it was always going like all the explanations and the thing, it was just behaving in a specific way, change the model, use something else, and sorted the problem. Now, in terms of going back, technically depends on how you break down the work so that you can, I don't know, do reverts, commits, and so on, abandon branches and stuff like that. So this also happens, we can do all that. But on the process itself, I think for me at least, besides rewording and changing different approaches, which again, I found this that sometime, although I was changing what I was saying, explaining, giving details and so on, it didn't work with the specific model, so I switched to another and got better results.
Thank you. More questions?
Switch too fast.
Okay, hello. I would have the following question. Assuming that you use ubiquitous like words and the model understands what you're explaining and so on, at least in my experience, sometimes I got to the point where I feel like it's lazy and it doesn't want to actually fully implement or work on the specific thing. Do you have any experience with that, or maybe I'm doing something wrong?
Well, probably that can happen. I think, I'm not sure if I had any experience, like if I try to think about it, I'm sort of on the opposite side, I feel like. My experience is on the fact that it tries to implement too much, not too less most of the time. So, but I had different moments where it was definitely going into the bad direction, but not implementing stuff, I always felt like it's very keen on implementing tons of stuff. So it will just go and implement the more code, the better. Like it's just verbose, not reusing stuff, implementing things. Again, you have to be explicit about, I don't know, dry principles, reuse things and so on. Most of the time when I look at the code, I see things re-implemented, not implementing them. So I'm not sure.
Maybe I'm explaining it wrong. Sometimes it finds it easier to hard code things, and you need to dig in and find them, and it feels like a lazy way to solve the issue or the task. And instead of coming up with like an elegant solution, it has a tendency, even with Cloud Opus, to hard code and be late. At least that's how I feel like it is. Yeah.
Yeah, but that usually, I agree with that, totally agree with that. However, in experience, I found that if I explained what I want exactly, so do not duplicate that or do not hard code, implement it in a specific way, so I give more guidance to what I want, usually the problem, it's sorted quite quickly. So I didn't get into this loop where it didn't want to do something in a specific way, but the other way around, like I think it's quite quick to react. So yeah, sorry.
Thank you. Toby?
I mean, you're working for a SaaS company. I'm interested in your point of view. How does it affect? I mean, we are living now in a world, so the last 10 years, where SaaS companies were guiding our company processes and stuff like that in the way how they want it. With approval processes and stuff like that, everything what is integrated in this ERP world. Does it have the potential to really come back to a national way of working, and we get rid of these SaaS companies, so that we destroy it, actually? What's your point of view on that?
I'm not sure if I understand the essence of the question. So if I think that the AI in itself has the potential to change the paradigm, instead of having the big SaaS companies have a different kind of model. I think this is a personal opinion. Based on the evolution we've seen so far and the potential in all this, I think yes. So I think the way we are evolving and what we have now and the things that were proven so far, I think it goes into the direction where things will change, like in the way I think internet changed what was there before. Maybe social media is a new thing, mobile was a new thing, and so on. I think software will eventually be different. However, I'm not that, I don't know, visionary to see how.
That's why
Yeah, I think yes.
Yeah, personally, I think it's a very exciting time because we're coming back to behave like human beings in companies. Because it's get rid of this, that they are training us like apes to follow a process where somebody thinks this is the process. No, it's about satisfaction, it's about product creation and stuff like that.
Yeah.
That's why I fully agree, and I really liked your speech, because it's about the fundamentals, and we're getting back to that fundamentals and get rid of this noise around us.
Yeah.
Yeah, cool. Thank you.
Thank you.
Thank you very much. I think it's time for a break. Thank you, Bogdan.
Thank you.
5 minutes, glass of water, back here. So it's, what time is it? Please, 50, so 5 to 8. See you here.
Așa că de asta zic că nu știu dacă am înțeles de rezolvat, dar mi-a zis că am vorbit cu tine și că i-ai dat niște critici pe voi, am zis una dintre ele, sunt sigur că a rezolvat foarte bine.
How was the break? Long, short, good? Too short, yeah, I know. So, now Costin Vilcu, a cyber security expert, thank you, will give us an view about how cybersecurity is evolving right now with AI, and also speaking with him a bit in the break, he told me that he's not doing things only for, let's say, corporation, but he's doing also security things and explanation also for kids and parents, of course. So you can ask him also these kind of things at least after the presentation. So,
after my presentation.
Thank you.
Welcome.
Nice to meet you. Thank you for inviting me. Thank you, Bogdan, for using my first slide. So if it goes wrong, I can put the responsibility on you. If it goes well, I take the credit. I'm usually trying to deliver by interacting with people, and I will do that tonight also. For this, I prepare some cheat notes. I'll ask you about, the reason is that I'll try to show you that you already know a lot of things that I'll be presenting. And by the way, because it's an AI day, of course this is generated with AI, my presentation, was on purpose. And you get one beer from downstairs if you know which agent I used to... Anyone?
Jamie, probably.
No, I put that after. I put that as the logo after.
We don't believe us.
Thank you. Yeah, no, you're right. So you get a beer. What? Okay. So the plan is like that. Because we're also late, pretty late, I'll try to skip the question phase in the end. So we'll be answering questions during the presentation, right? Mostly I will ask questions, but you can also ask them. If I don't like it, I want to answer, right?
The other one. The other one.
Your colleague will be presenting this one.
The other one.
Oh, the screen sharing doesn't work? PDF. Okay. Now you won't see the notebook LM, right? So I did it. So this slide is just for me to show you that I've been in a lot of organizational cultures, different ones, European, global, local, state, private, and so on, which was very helpful for me. And the topic, SOC transformation in AR era, I want to know, I believe you all know about AI somehow, at least to write a prompt, but do you know about SOC? Just a few? Okay. So for the other one, SOC, it's Security Operations Center, right? It's like NOC, but with an S. NOC, you know what it is. And of course, in the era of AI, this is also NIST transformation, and at the end of the presentation, we'll also know why. So my first question for you is, why do you think the current model is not enough? Since a few of you said you know what a SOC is, can you tell me? In the AI era, why the SOC current model is not enough?
Because they just can replace everything in the chain.
Sorry?
Because they just can replace anything in the chain.
In what chain?
The entire SOC chain, from the operator to the CM to the so on.
Okay, that would be a benefit, but what is the drawback of the current model?
What drawback of the
Yeah,
current
or the
model?
problem?
Well, They are all trained on the previous data or something?
They are not trained.
Depends.
They are human-led.
Okay, so you're referring on... Okay.
The current model of the SOC, how the SOC is working right now. The classic SOC, the legacy one.
They don't keep up then? Probably?
Yeah? Do you think, you know how many events or alerts a SOC analyst have to take a look on a daily basis?
So we
Not a
have,
million, but
we have a car fleet of 60,000 cars, which is creating 1,000 events per day.
on each car or the fleet?
The fleet.
The fleet, okay. But other than the fleet, you have the IT, you have... Yeah.
Other than the fleet, I don't know.
Okay, let's see. So, it takes, we have 40% of the alerts that are getting through the SOC not investigating just because of not enough people, and not enough resources, let's say, right? If we're talking about large enterprises, there are up to 3,000 alerts coming to the SOC. And the, sorry?
Which time a day or 3,000 events a day?
Yeah, daily events. But average for smaller companies, it's lower, but for the bigger ones, there are 3,000 per day. And imagine if you're an MSSP, so if you deliver security services, you get alerts from all of your customers. And another problem is that they're not coming from a single source. They are coming from different type of equipments that should be integrated with the tool that are receiving, usually the CM. For what is a window of exposure is the time that from the beginning of an incident, of an attack, let's say, until you actually try to do something about it. And considering that it takes less than an hour for a phishing attack to actually infect your whole infrastructure, if you take a human to analyze that alert, it will take him, her, they, usually 70 minutes. Those are some averages from the reports. The main problem is, and probably also because of AI, that there are not enough humans in the SOC comparing to the number of alerts. Not only that, the AI it's also used offensively, so the attack surface increases. Other numbers or other problems, let's say, that you can think about? You're using cloud, right? Do you think something about cloud that can be an issue in this legacy model of analyzing the security incidents? The visibility. In the cloud, we don't have enough visibility, usually because of the cost, probably. Not the companies don't usually buy all the features that will enable them to have all the logs, all the visibility in their cloud environments. So if you don't have visibility, then you cannot pinpoint that it's an actual incident, security incident or not. You might say it might be, so you don't take the correct decision. Another issue is that you cannot build, because you don't have this visibility, you cannot build a threshold, like a baseline for what is correct, or what is normal, or what is not normal. It's all clear right now? You can ask me a question because I try to not have a session at the end, but you can ask me. No.
Or if it's available, it's way too expensive. So if you ingest a lot of logs, yes, it becomes a cost issue.
Exactly. Usually nowadays, not the companies, but the solution, the CM solution, they are usually you pay by the number of ingested events. Right? Okay. So this is what we could miss, right? And what are the current model, let's say, problems or issues that we can solve? Maybe, we don't know, but we hope we solve with AI. So these are four, let's say, stages that we can, where we can use AI in the SOC. And the first one, the autonomous triage. Now the triage, what is a triage? It's the decision that a SOC analyst does to say, okay, this I should look at, or this is not worth it, this is a false positive, right? That will be the biggest increase in the time spending if you use AI. Because if you train the model to discern, to determine if this is a false positive or not, then you have more than 50 or 60% of the events put aside, so the human can focus on what it's supposed to focus. The next phase is to increase the context, to give more context to the analyst, so he, she, they can take a better decision. Can you give me an example of a security event, let's say, that will make it to the SOC?
A library that is vulnerable.
Can we let other people talk also? Well, thank you. Yeah.
A brute force attack.
A brute force attack? Who said that? Okay, a brute force attack. A brute force attack, when, if you don't know it, it's when someone attempts to try a lot of credentials in a small amount of time, right? And this will be an alarm that an event that will get to the CM. How can this be enriched? So the AI can be trained to give more details to the human analyst in terms of, okay, this is a brute force attack because of, so add some reasoning, and this is how it came to, this is where it was, this was when it was first saw, in which system. So all this data can be delivered to the analyst to help him decide, okay, this is a true positive, I should move on investigating. So that's an example of the enrichment. Predictive detection is what it's, I think it will be very helpful in automotive, because you can create a baseline, what is normal, and actually can depend very much on the industry. That's why I said that in automotive, because you have a lot of telemetry data. You can have you can construct a model with a good baseline and then decide if it's an issue, a security issue or not, based on that baseline. And the genetic orchestration was the final phase when you actually onboarded all the AI in your SOC, when you can teach or train the agent, an agent to take decision, like enable a firewall rule to block the traffic, or close a switch port, or maybe send an uninstall or a quarantine to the EDR to quarantine the specific file, and let the agent do that, of course, with specific guardrails, right? Actually, before moving forward, what do you think augmentation, not replacement, would be in this context?
Helping the security person, security engineer, who is responsible in finding out root causes for issues for security alerts, for example.
Yeah, thank you very much. I'm sorry if, so you do the walking, okay. So yes, augmentation, not replacement, actually means that we do not need to replace the engineers, right? We need to make AI, in this case, help them make better decisions.
Yes,
right. Yes?
How much of this transformation is driven by LLMs, by this change, like by the LLMs themselves, and by specifically train models for security, because I was under the impression that the security space benefited from AI before the LLM. So one of the applications of traditional, it's called the traditional AI models, neural networks and so on, was helping security before the LLM era. So how much of this is driven now by the LLMs versus purposely trained models for security? As in, for example, to understand traffic patterns.
Yeah.
Do you need an LLM for that, or you just build
If it's a specific,
train a model?
if it's a specific industry, a specific type of, let's say for the general IT infrastructure, not necessarily you can use a general one, but for specific industry, you should train your own one.
Okay.
In financial, they already did it with the Bloomberg AI. I think every industry that wants to be a leader should do the trainings on their specific data.
Okay, and that has changed now with the LLM's revolution? Or
Yes. I mean, I don't know what you mean by security had it before.
I mean, being able to catch security alerts pre-2021.
Yeah, well, it was done by static rules. So there was CM, there was some CM engineers that look at the rules. Okay, if I have the event like a login event from a Microsoft Windows system, and then I have a privileged user like admin, and then I have a lot of traffic going outside from that machine. These rules in a sequence, in an amount of time, would mean probably that there's information. Yeah, not the word that I work. That's something like that. It would be an event,
okay.
Right? But there were static rules predefined. There was no, reasoning or model.
Okay. And then just another one. You mentioned initially that one of the problems in SOC was the cost, the fact that you don't have, like, it's expensive to have all the logs in just all the data and so on. By doing this automation doesn't make things more expensive, because in order to make this work, you have to have the logs. And
The idea,
pay
yes.
for the logs plus.
No, you don't pay for the amount of logs that get into the CM, because you use the AI earlier, before ingest them in the CM, to make the decision if this is worthy or not to go there. That's the reduction of the cost there. So the idea of this slide is that AI in the security, in the SOC, shouldn't replace the engineers, the SOC analysts, or the people working in SOC, but should help them, leverage those number of events to enable them to have more time for decision. Okay, next will be, what do you think it will be a return of investment for this one? Before clicking, let me have some answers.
So if we implement AI
If you use AI in the way that we presented, what will you gain aside money, before money?
Time.
Okay, time.
You cut the time to go to the real threats.
Okay, so you make that window smaller, right? Between the showing the event and
faster reaction.
Faster reaction. Okay. Speed.
Yeah.
I need you to be interactive.
I personally believe that the costs for security will explode.
Okay.
Because it's a theoretical thing that, okay, of course, everything is making us more productive since humanity is existing. I would say when we started with fire and stuff like that.
Yeah, security is a break.
So since then we have a productive, but here the amount of tech vectors, what we have, and the speed what is coming up requires a hell of investments of companies in order to secure that. And I think from a sovereignty perspective and from a brand perspective also, security becomes a real strategic asset to manage this, That's why I think it's not becoming cheaper. If you mean that, I think the costs are going up. We need to consider that as a brand asset or a company asset to become that, and not at the end of the
actually,
day,
what
software is launched, let's make some security on it, like we did it in the past. I think this is what this is about.
That's correct, and actually money wasn't on my next slide. But yeah.
But I think also it can help a lot. I mean, security means 24/7, 365.
Yes.
And especially when you do that out of the European Union, you need to deal with working law and stuff like that. So you need to manage that 24 hours a day. And I think here it can help a lot to manage that effectively without going into that you're within a working law.
Yeah, so, because I think what you're trying to, what I'm understanding is that you don't need to scale the human that you need to hire in order to be able to keep up with all the new thing that you have to protect. And this is the one thing that AI augmentation will help the SOC. And by reducing another ROI that it's not maybe very obvious is the fact that you reduce the risk if you have if you enhance in any way your SOC activity. That was the reason. Now you may have to make the comparison with without or with, right? But yeah, I need this debate. Okay.
My question would be more in the lines of, in the last couple of 1-2 years, most of the breaches that we had were based on credentials that were lost, and somehow the attacker also spoofed the location, like geolocation, and they got in. They didn't have anything to stop them pretty much, or figure out, even if they were using like Microsoft Sentinel.
Okay.
That's pretty much similar to what you mentioned before. And somehow those attacks keep going in the last months also. So how do we get to the point where we have zero trust, and that would also imply that how can we enable our organization to be able to be resilient against those kinds of attacks? Even with MFAs and cookies.
It's not necessarily an answer related to the presentation, but to train your people to not reuse their password. That would be my first thing. Of course, also these breaches are going to the dark web. They are sold there, and another defensive vector is to monitor those forums, get input from what is published there, what announcements are done. Okay, we sell this data from this company or stuff like that, and ingest that into the CM so we can take decision. Okay, we have information that in this industry there's something. Not sure. They don't usually show you the data when they sell it, but they say, okay, we have, and they give you some samples, so you can buy it if you want. But if you have a knowledge about this situation, you can input this information into the SOC defense. It's called threat intelligence. So you can use this to enhance your detection mechanism.
But I think you're right. This is a very interesting question. I mean, we know that the biggest threat in terms of cybersecurity is not a mistake or an exploit in code. It's the human being.
Yeah, but who made the code?
If you think about social engineering, how an AI is imitating certain things and the capability, and I guess these capabilities will improve.
Yeah.
We are at the starting point there. Then it becomes very interesting how the humans are going to manipulate it. And I think it's not done with training the people, because the people are not recognizing it anymore, what is truth and what is not truth. And I think that is really a challenge. That is really a challenge because it's not the mistakes in code. What is threat? It's the social engineering.
And even if, since you can spoof cookies, for example, have
Yes.
like a
Yes.
hire that logs in on Teams on a browser, and there might be more information to be had. Maybe he has like a chat where he logs in like a password and so on. So yeah, it's a bit iffy.
I agree.
There's one silver lining. It's a problem for everybody. So.
Yeah, it is. But,
that's not the problem anymore. Yes.
I was talking with Andrei, the offensive usage of AI is far advanced than the defensive measures with AI. So we also have to close, or at least make this gap smaller. Okay?
One comment.
Yes.
To add to this idea, very recent news, one of the big security flaws found in the Linux kernel.
Yeah, two of them actually.
Yeah, from what I understand, they were found with the use of AI.
Yes, that's a good thing on the defensive part here.
And now humans exploit it. So.
No, human can exploit with their mistake later. Well, was to write on the mem, but in one of the games, not real trade.
And to put some pressure also on the software developers, the mistakes in codes happens because of humans, right? Or used to, because now they are.
Don't worry so much about this.
Yeah, I know.
If it's 25 years there and nobody exploded over 25 years, yes, I agree. If a model like Mythos would come now and we use it, if offenses they find the mistakes. The real threat are human beings. And when they are manipulated, especially in companies.
Yeah, but in the form that you put it, I'm afraid to say it because it's not politically correct. Okay. This is a comparison with the old, or not, the classic SOC KPIs and the new one when we have AI-enhanced SOC. We'll not look at the total alerts that we log, but we look at how many of the alerts we actually escalated because they are true incident, true positives. We'll look at the mean time to contain and mean time to detect, not on the mean time to respond or how many analysts we have as a headcount, but how many hours did they work. So the measurements, the KPIs will change when you have AI. You mentioned at some point about the regulations, right? And I have a slide of that also. Actually, the next one, it's the small difference between the classic, let's say, enterprise SOC and what will be needed or what is needed in the automotive SOC when you get data also from vehicles, because you have a lot of other attack surfaces there, which before security was on the rise, nobody cared about those. But now, as the cars are getting more, let's say, software full, they become also an attack vector. So there's an increased number of events that may come from there to the SOC. Question about this slide? No? You are pretty silent.
Question, but
On the previous one?
Yeah. So the AI metric, it says true positive yield,
Yeah.
which is this like a shorthand for something that's more complex, or are we looking specifically and just?
No, what is actually a security incident? Not a lot of noise which happens now because of those $3,000 per day that 2 people or 3 people or 5 people needs to look at.
What about the false negatives? Are those accounted? So things that a
So the undetected ones, those ones will be the ones that you don't know about. So you'll get into a breach when you find that you had a false negative.
Well, yes, but in general, I mean, before LLMs, you would be able to tune based on, like, you know, a corpus of data. You would be able to tune the statistical model to, like, for example, minimize false negatives. I was curious if you're using LLMs for this task, how you would be able to do the same thing.
Maybe there's a difference in the meaning of the true positive here. So in this table, the true positive means when the AI or the SOC analyst actually detected a real attack.
Okay, yes.
The false positive will be when it's alerted as an attack, but it's not. The false negative will be when it's not detected as an attack, but it was an attack.
Yes.
And those one, you cannot, I mean, if we go further, you have to get the execution of the exploit, or let's say the breach, to realize that it was a, so it will be too late.
Fair enough. I mean, given not at, obviously not at inference time, not at runtime, you wouldn't be able to do that. But when, for let's say classical statistical models, when training and you have the corpus of data, you could adjust these things. You could say, okay, I want more false positives, but I want to never miss.
Yeah, you can train that. You can put.
Yes, but how do you do that with an LLM?
I don't know. Okay. I'm not an AI expert. I'm a security expert. Okay. So I'm talking about the benefits of adding AI, which I'm not an expert in, to the security operations center. Okay. So I think AI experts will be better in answering that.
Thank you.
No problem. This is a slide regarding related to the previous one, regarding the difference between classic, let's say, an enterprise SOC and a vehicle SOC, right? Because here we have another other things to look at, and actually, this is the big thing that I think may help a company that are trying to grow a security service, security operations center service. Because when you have this amount of data and so specific to your industry, and you get to use it in order to create your own models that you can use them in security, then that will be a baseline for you to be more competitive, and also to selling it as a service. There are no other industry that can get this data, right? Other than automotive. The same way where, like, there's no other data that the pharma industry can get because they have specific data. And you mentioned regulatory. Yes, we need to make sure that we match all the regulations in the industry, but not only in the industry, but also the general ones like NIS, DORA, whatever we have in Europe. But of course, also the specific ones in automotive industry. What does it mean that we need to? I mean, this is also a drive for getting security onboarded, right? Because you need to be compliant. But the use of AI in this, so in my presentation, the use of AI here will also help you because it will, by having a help, you can get more straight data that, okay, if we're using this, we actually can show that we are compliant. So you don't have a human that needs to search, okay, we are compliant or not. You have an help with AI. Questions? Only 5 minutes left. No? Okay. Deployment path. Sorry?
So
second cheat sheet, yeah. I wanted to write big so I can see because I'm 46. So, as Bogdan said on his talk about the software development, there's no bandage like one switch on and off to apply this AI. You need to first apply it. You need to apply it iteratively. You need to use face. You need to, as you mentioned, with the code spec. We have the pain points that we need to. So we need to know them. We need to define them very well when you start with AI. Why? Because this will be put in the model and in the agent. Right. So first of all, know yourself. It's very similar with what Bogdan said. So you got the idea from the beginning. Only he talked about software development. Here we talk about adding AI to our SOC capabilities, but the principles are the same. Know exactly or the best you can with what metrics you want to look at, what we want to improve, right? That's the first phase. Then don't just put it there. Use it initially with using APIs, connect to the different models that might be out there. See, use the RAG, it's retrieval augmented generation. Yeah, use this kind of sorry, I missed the word.
Structure.
It is structure, yeah. So because by using RAG, you can actually teach more about from the output that you get. You can also feed them back to learn. The phase three, it's you'll run it for a couple of months, depending on how big the project is, maybe more, and then adjust it also during that time. And in the last phase would be to add an agentic power, let's say, to when you can enable autonomous agents. So not fully autonomous, but in a specific guardrails. You shouldn't do that, like you shouldn't shut down, the CEO PC. So you can put guardrails, of course.
I actually have a question here.
Please.
In this model, I mean, on the previous slide, the result is full automation, right? And you run it, as you say, there in a monitoring mode.
I'm afraid to run a fully automated agent right now, because it happened with bigger companies. But yeah, the final target would be to have a fully autonomous.
When you run it in monitoring mode, it means that it learns from the human analysts and whatever resources it can find on the web, or whatever resources you put at its disposal. But how do you deal with new attack vectors in phase 4?
Well, there's not really not so many new attack vectors, right? One of the cases, let's say, would be the one that we discussed with a false negative, right? The ones that it doesn't know anything about it. But then when it happened, you'll feed him in, you won't catch that one. But based on what I'm saying is that you reduce the probability for this to happen, because you not only have the data input by what is already in the CM. So there are rules in the CM right now that says, okay, if you detect that and if you detect that in this phase, in this sequence, in this amount of time, this is suspicious. The autonomous thing will take the suspicious level to, let's say, we'll look at the suspicious levels, we'll decide to do an action like implement a firewall rule, or maybe isolate the host, or I don't know, quarantine the specific file. But beside these rules that will be learned, there will be some behavioral, let's say, of the traffic or of the events that are coming. So this behavior, let's say, that a human wouldn't be able to analyze it in a real time in order to take a decision, and that would be the autonomous, let's say, benefit of the AI. For sure, it will not be 100% correct, but as you run it and have it more time, it will be better.
Yes, I'm just worried. I mean, in the model that you described, the monitoring mode seems to be limited, 1 to 2 months in there. You can run it for longer, you can run it periodically.
The monitoring here refers to you as a human look at how it behaves and how it learns and what decision it makes. It doesn't mean it learns. In the monitoring mode, you actually let the model run, but you as a human with experience in SOC, let's say, you look and see what decision it would make and adjust those. That's the monitoring mode there, not the learning of the model. Presumably you have a model that is very good, let's say, or adaptable to the security elements, and you put it in the SOC where there are already rules of detection.
So what do you do when new models come up?
What do you mean by new models?
You said that you monitor a model, and you said that it is adaptable. However, the model is a model, and they get replaced periodically, they get updated.
I think you're outdated.
And you rerun the entire 4 phases?
Not necessarily, but it depends. Again, I think the question goes more again to the AI part than to the security side. So you get to my limitation of answering AI questions. So who's more experienced in AI can
I think
maybe
I can
help.
answer. So
Yes.
in general, when you put a new model for whatever system it's operating upon, you have kind of a baseline set of evaluations with some scores, and basically you kind of rerun those in whatever way with the new models. Depends in general. So this is how you do it, but you need kind of a baseline, you need evaluation, you need kind of a scoring system to define for yourself, in this case kind of security. So I don't know what would be kind of the criteria for the score, but this is usually how you kind of operate model deployment into an AI system in enterprise environments.
Okay then.
Yeah.
Are you okay with closing this? On the last slide was just what should be the drivers for a company to adopt this. But I'm looking at the clock and I know that there's another colleague that needs to fit in 15 minutes. So there's actually one more slide, but this is not important. Thank you.
I have a suggestion because we ran 2 presentations in the time for 3 presentations. So what if we do now without the break, the 3rd presentation, and then we do then. Okay, so let's continue. We continue. Perfect. So I would like to invite Dana to the stage. So Dana, she's our senior product manager. And she's almost from the beginning of Deconim Romania. She's here in the team. And she's working in a project, in a data labeling project, where of course AI gets in. And she will challenge a bit the comparison between patch and pray and build something with AI which lasts. And Dana is the kind of person who is usually challenging you on things you think you know or you have an opinion about. And I'm sure she will challenge us tonight with her presentation. And Dana, if you're ready, I'll simply give you the microphone. Do we keep this one? No, okay. No. Perfect.
You okay?
Share screen. Share screen. Sharing.
Andrei?
Yeah, loading.
Loading. Good.
Și voi ar trebui să vedeți ecranul celălalt. Dar exact, nu trebuie să se vadă așa. Ar trebui să vadă ecranul meu. Okay. Beta that. Now it's working. Okay, good. So I hope you still have a bit of energy left. I'm going to try to speed run this. So as Andrei mentioned, I have been working with a focus on data labeling operations for autonomous vehicles. This is a long-running project. It's been already a few years that this is going, and we are improving every year. And you will see that my focus is primarily on traffic sign recognition. So in this presentation, you will also see a lot of examples coming from this area, although I will try to cover the whole threats in autonomous driving as generally as I can. Okay. And besides this, about me, what I also wanted to share is that on a personal level, I am very interested in anything art related. So that is exactly why tonight I want to share with you my recent favorite artist that I found, this person from Glasgow, who is putting up around the city these fake traffic signs or modifying existing traffic signs. Exactly. So the question is, we took a moment to look at these and to process and to realize, wait, it's not a real traffic sign. What would an autonomous vehicle do in this case? And even if this person is, clearly well-intentioned and probably just wants to make people laugh and so on, the same mechanic with having a element that looks real enough to be a bait as a traffic sign is the heart of the most serious vulnerabilities that we can have in autonomous driving. So this is what we will talk about today. In general, I have 4 areas in my presentation. Talk a bit about the security landscape in machine learning, a bit about what's data labeling, why is it important, a bit about supply chain security, and hopefully I will just leave you with some good practices from the point of view of product management. So traditional software, we all know it's more like a locked room. You know exactly what's inside because you wrote the code to it. In AI and machine learning, things are very different. I would dare compare it more like raising a child, right? You set some boundaries, you provide examples, and then you just hope it learns the right lessons. Question is, what happens when your AI is learning the wrong lesson? What if somebody is intentionally teaching it completely wrong things? This is the main challenge, and this happens because the behavior is hard-coded. This is not, the behavior is not hard-coded, it's something that it's learned through the data. And the most impacted domains here are these autonomous vehicles, and of course anything related to medical diagnosis and so on. So let's imagine this whole machine learning pipeline as a supply chain from a factory. Imagine something very traditional. You have the raw materials, which is the data. That gets processed through the factory floor, which is the training area. And at the end, you have a final product. This is the deployed model that ends up in our vehicles. And these attacks can happen at any of these 3 stages. Firstly, in the raw material phase, this is the data collection. We could basically poison the ingredients before they reach into the training phase. You can manipulate the sensors, you can inject fake data, or simply steal private information. On the factory floor, in the training phase, you could corrupt the whole manufacturing process, meaning slip malicious examples in the training data that the model learns afterwards. You could plant backdoors that activate in specific conditions, or even reverse engineer the recipe for the whole model. at the marketplace level, when the model is deployed, you could attack the finished product. And this is exactly what we saw with these fake traffic signs before. You can have real world modifications of objects that would fool the model and create bigger problems. And every point is a potential failure. And these, aren't hypothetical threats. They have already happened for a very long time, I would say. I can share with you some quick examples from the research environment as early as 2017, where we had a team of researchers that were just modifying some images, adding noise to them, very subtle modifications, impossible to see with the human eye, but they convinced the machine learning model to recognize a panda as a gibbon. And they look very different, of course. And from 2020 onwards, we already have systems that, face recognition systems that are easily bypassed with printed photos. And an example from my area of expertise, traffic signs, we have a study in 2018 where researchers placed a very small sticker on a stop sign, causing the model to recognize that sign as a speed limit. So of course the consequences are very gravely because the car, instead of stopping, it was speeding up to the indicated speed limit. So we've seen that the attacks are real, right? And now the question doesn't get anymore if this could happen or not. It's what can we do about it? And the answer, I think, starts rather somewhere unexpected. It's not in the model or in the pipeline or the deployment infrastructure or so on. It already starts at the data. So before we can secure an AI system, we need to secure the data we're using for it. And this is why we have these 4 non-negotiable principles. We need to make sure that the data has integrity, so has been tampered with. The data has confidentiality, meaning we need to always protect sensitive data. Availability, we need to have access to the right data in the right moment in time where we need it. And authenticity. Of course, the data sources must always be verified. And we have some regulatory landscape for this in both EU and US. So before an AI model can recognize, let's say, a stop sign, because I've been using this example, what happens is that firstly, a human has to teach it what is a stop sign, how does it look like, where is it placed on the road, why is it applicable to us on that highway or not. And this whole process is called data labeling. This is where the raw sensor data becomes the ground truth. And in short terms, AI model learns like this is a traffic sign, a stop sign, this is a pedestrian, a bicycle, a vehicle, and so on. And the issue comes that if we have mistakes in this labeled data, the model will obviously learn the wrong things. So what do labelers do? Actually, labelers are highly trained individuals that annotate millions of images and various inputs from different types of sensors, including LiDAR, radar, and camera, in both 2D and 3D environments. And this whole thing is quite a big operation. I know it sounds a bit routine, but the reality is that it has to be flawless, because even if we label something wrong in 1% of the case, we already planted a backdoor that could be activated in the real environment and exploited. And this is exactly why the whole process of quality assurance is not anymore about just hitting some targets and we have a quality of 98% or something like that. It's not a production metric anymore. It's a matter of security. So we need to make sure that the data is properly verified always. So now I would like to talk a bit what happens if someone intentionally try to break your model. These type of attacks come usually in 2 forms. These are the digital attacks that I've briefly mentioned earlier, with this manipulating of the image with noise, transformations, scaling, and so on. And the physical attacks, these are the real-world modifications of various objects. Stickers, graffiti, patches, patterns, and so on. And this is why they are so effective. Machine learning models don't understand the world as we do, or not yet. So they learn patterns. And the moment you know the pattern, it means you can exploit it. So how do you defend against an attack you have not seen yet or not even sure how it's going to look like? The universal answer is that you need to train your model for it. This whole process is called adversarial training, and it means you deliberately expose your model to this type of adversarial data, so the model will learn to recognize it and resist it. In very simple terms, the model at the end should know that this stop sign with graffiti on it is still a stop sign. The stop sign with patches, stickers, is still a stop sign. The one that is, weirdly rotated, like it happens in many cases here on our roads, is still a stop sign. It applies to us, and so on. And there is, of course, a trade-off here. What we have observed in practice is that usually models who are this adversarial trained quite good perform a bit worse on perfectly clean data sets. But, it's, I would say, a bit the equivalent if you're wearing an armor, right? You're definitely much safer, but a bit less agile. So now you've secured your data, you harden your model, you have your adversarial training done, but there still might be a quite important thing that you're missing, and this is the supply chain security. So what's happening here? This means that every third-party service you use, this includes the labeling suppliers that often are other companies in themselves, the cloud infrastructure, open source libraries, all of them are potential attack vectors. So if an attacker maybe cannot break through your front door, it will definitely try one of your vendor's doors. And we actually have a real life example from earlier April, last month. We had a security breach that was affecting a very widely used JavaScript library. What happened, there were some malicious versions published with the purpose of exfiltrating data. They also had an auto-destruct mechanism. And these very popular JavaScript libraries were actually used in most of our supplier tools. So 2 days we had to shut down everything. We fixed it, it was contained, and we had the right tools in place to not have it become a bigger issue. But it's just a signal for all of us to be aware that these things actually happen, even if it doesn't seem so likely. So, and outsourcing labeling work is actually a very common practice. So we have specific companies with the right talent pool who are good at doing this. So that's why a lot of the main manufacturers work with them. And what happens if one of them is actually affected? It could mean that all your training data, including sensitive information, because all those data has GPS, VIN numbers, and so on, sensitive info, this could be exfiltrated. Worse, an attacker could also slip malicious labels inside your data, and you could not even find them until the model is deployed. So each link in the chain is a potential attack vector. So what can we do here? When we select a third-party labeling service, we need to be very careful of the steps that we take. So we cannot just go on references on, I don't know, Toby has a good company, I'm going to work with him because so on, right? So we need to look at their certifications, and we need to look at their whole pipeline, their data handling process, who has access to the data, when, what security logs do they have, can they prove everything, and especially what is their incident response plan. Will they notify us in hours, not days, and so on. And of course, we have contractual frameworks for all of this. But the main takeaway here is that we never stopped at the contract level. We need to have a continuous monitoring of whatever the supplier is doing. So we could also, for example, watermark the data to trace for leaks. We could also conduct random samplings at all times. And in general, we always have to maintain this right to audit whatever the supplier is doing at any time. And every vendor, in the end of the day, it's a partnership. We want to work with them for a long time. But in the same time, we know that is also a potential risk. So we just have to learn to manage it both. And security is not just about prevention. So after looking at what the vendor does and how they handle the data, we also have to look internally at our systems. How are we handling the data? Do we log everything? Do we have this forensic evidence of what happened to the data in the pipeline? And specifically, we need to know who accessed the data and what data sets were used for which model. And another important point is monitor the model performance. So depending on which model we use and for what we train it, we have different predictions for its performance. And the moment we see something out of the ordinary there, it could mean a potential attack, and we need to investigate immediately. And of course, for all of this, we need a clear incident response plan that also includes proper communication to everybody affected, all these forensic capabilities, and so on. So, lessons learned at the end. From my side, as a product manager in all my career, not only here on working on autonomous driving, I think I've learned that security is something very critical. It should definitely not be bolted in at the end of any kind of product you're doing. This should be part of every roadmap from the beginning. It should have its own resources, its own budget dedicated and included in all the discussions. And if we're looking specifically at AI and machine learning, what does this look like in practice? There's 4 main areas in the machine learning lifecycle, and security has a critical role in all of them. In the design phase, I think it means you need to think about the security before you start writing any kind of code. Then in the data phase, it means you definitely need to try to train your model, even for the attacks you have not seen. In the model phase, you have to always be prepared for everything that comes, even unknown, and always treat every label as the potential attack vector. And in the operational phase, it means you never have to assume that you're done. It's not like the security chapter ever closes and that's it. And I think these are not all theoretical ideas. They're rather principles that stand between us having a reliable and secure AI model or something that can be really easily manipulated, including with some stickers on signs. So I think at the end of the evening, what I would like to say that today we stand at a crossroads. So AI systems are present in our life, whether we like it or not. They are in our vehicles, in our medical system, in our critical infrastructure, and so on. We just need to adapt. And my main lessons are that security has to be built in, not retrofitted at the end. For me, data labeling is a critical security control point that sometimes it's overlooked, and actually many threats originate at this level. The adversarial robustness for your model is not something optional, it's something mandatory, especially in these high-stakes domains. The supply chains, all of them are attack vectors, so we need to vet our partners and make sure we have a continuous monitoring of everything we do. And of course, privacy and security are inseparable. And I think most important, if I want one takeaway from this presentation, is that security is not the job of the security team, it's the job of everyone involved in this pipeline, from the first data labeler, the product manager, the machine learning engineer, and even the high-level executive. Everybody has a role to play in this. So coming back to our dear Glasgow artist, you know, he just wanted to make people smile, but you need to keep in mind that the next person modifying a sign might not be so well-intentioned. So it's our duty to make sure that we build the models that will actually know the difference. Thank you. That was it. Yes.
I want to congratulate you because you're the best promoter of security. I mean, you should go to every team to do this. I mean, you touch every point. And I remember the Dutch hacker, which printed a T-shirt with license plates.
Yeah.
And she went to where the AI camera were, and other people start receiving tickets, fees, fines.
Yeah, exactly.
Yeah,
exactly.
That's another.
That's clear. Yeah.
Thank you.
Yes?
I have one question. It's not really related to security, but more to this data labeling. So are you doing this data labeling manually? So you are receiving inputs coming from the car,
Yeah.
but then do you have people that are actually doing this?
Yes. Yes.
And have you thought on integrating some sort of this new LLM that supports image processing?
Yeah, we have partially integrated this because we have different labeling modes, we call them, right? And one of them is a very simplistic labeling, meaning you have the recording for traffic signs. I'm going to talk about that. You use the recording for the front camera. And you just need to detect very easily where are the traffic signs. And we have an AI implemented for that. And then a human comes and starts telling, oh, it's a stop sign, it's a yield sign, it's rotated, it's red, it's broken, it's fallen down, it's so on.
But wouldn't this LLM be more effective than having 10 people doing the same?
At this point, it's not. At this point, it's more effective, and we keep the judgment at the human level side. So maybe in the future it could be, but we're still training the model to be better and better at this. But for now, the judgment is at the end of the day, a person has to decide and to say, okay, this is this and this is that and so on.
Yeah. Okay, thank you. Very nice. Okay.
Toby?
I don't know whether you know it. I mean, you do that now a couple of years. Do you know how many security incidents we have because of wrong or misinterpretations of the traffic sign at the Volkswagen Group? Because, I mean, the software is done in, I don't know, 5 million cars or something like that?
I can imagine.
Do you have numbers for that? Or
No, I don't have
Can we
numbers.
find out?
No,
That would be
unfortunately.
very interesting, I think.
No.
Not sure if it was raised in the presentation, but I also think cost is a very important factor in the whole chain, because when you do traditional software development, it's much easier to fix a broken window or whatever with a few lines of code than just ship it or put it in cloud, even easier. It's completely something else to see what the part of the label data is corrupted, take it out, run the whole pipeline of the model, test it again, and then deploy it. So, yeah, I think it's quite a big challenge on this part, and why is it so important, right?
And most of the things we find them, not necessarily that the data was corrupted, but we find mistakes in the label data, and they are just human errors. We keep the decision at the human level, as I said, but humans also make errors. They are sometimes tired, you misclicked, and so on. The errors that are, how can I say, could be recognized from the labeling process can be handled automatically. So for example, it's easier to, if I give you an example, you need to set the shape for each traffic sign. If somebody missed to set the shape, it's already an automated thing. So he gets a notification, you cannot finish this data unless you put in the shape. But if somebody selected the wrong shape, we might find it in the quality assurance process. If we miss it there as well, we're going to find it in 6 months at the next release of the model. And we're wondering, why is this not going well? And then what we have, we do specific new data sets. We identify these problems. Let's say, I don't know, for what reason these signs are not. We have a real problem I can share with you. LED signs are very hard to recognize. They are very different. A lot of them have words, contrast, intensity, the panels look different, and so on. So we labeled a lot of specific data sets only to improve the recognition of the LED signs, just with this.
Thank you.
How much did the emergence of diffusion models revolutionize the space in automotive vision AI?
Sorry, can you repeat it again?
When diffusion models came up and became the new state of the art in vision, did this revolutionize the automotive industry's
Well, I don't know if I can say they revolutionized it. There were some improvements, but in case of any, let's say, major breakthrough in the industry, it takes time until it gets implemented. It's not something that can be already put into practice tomorrow. So usually any kind of benefits for these type of things we see on the long run. And I would say they are rarely found in some qualitative reports, although it would be interesting, right? Even for the teams working on it to say, we made this change, this is how our workflow improved.
But not in any way disruptive as large language models are for the industry that they force people to adapt to use them.
Yeah. Okay. Okay.
I was just wondering about the wrong signs. What is happening if you have a stop sign and it's wrong? It's just erased from the model, or how it's...
What do you mean by wrong?
It's tilt or something that it's not very
no.
visible.
We are doing this adversarial training, so the model needs to learn that it's tilt. So we provide the model enough example of tilted signs, so it knows how to recognize even those. And this also applies to the signs that I keep coming back to this example because I see it very often on our streets that are wrongly placed. Or rotated.
But it's still a valid stop sign.
Exactly. Okay. So the information doesn't come only from the one sign. Usually in this type of situations, you see more signs around, so it's a more complex decision. The model at the end doesn't just see a tilted sign and suddenly decides I need to take this into account. It needs to learn the context. And this is also part of what we're doing.
Okay.
Yeah, and to understand where it's coming from, where it's going, why this actually is a stop sign, and it's for me, and so on.
So it's validated by the context too.
Yes, in these kind of situations. But just at looking at image recognition, it also needs to learn that a tilted sign is the same type of sign that the one that is viewed frontally, placed correctly, and so on.
Okay, thank you.
Thank you. Dana.
Yes.
First of all, great presentation.
Thank you.
So my question to you, for all of us here to listen, would be, what do we do when we want to provide the model enough edge cases for a certain situation? So to make sure that we find enough data with tilted signs would be the easiest. Let's say weather conditions or things that are a bit trickier to find. How do we manage that?
Yeah. This is part of the previous layer. So before the data actually gets to the labeling, we have this type of pre-selections. And the pre-selections are, let's say, prioritized and organized by the model performance. So we notice that the model performs not very well on night conditions when it's raining. So we basically ask the pre-selection team, which is a completely different team of people, we need this type of data selected. And either they use some AI on their own to pre-select this data, or we could take information for this type of night or daytime data. We can take the date of recording because we already have this info and we can already classify by separate data sets. And if we're looking for a specific sign or weather conditions and things like that, we have a different team that is doing this pre-selection, also with data labeling, either manually or with AI.
Thank you.
The unfair questions are coming over the end.
No, not unfair question, but I do have a question. What does the car do if it reaches an intersection and doesn't understand the traffic signs and whatever? I mean, it reaches the point where this might be a stop sign or not. I don't fully recognize it. What does it? What's the default?
It defaults to the driver. That's what it does.
What?
It defaults to the driver.
But if I know, I'm just taking this maybe a bit too far.
And
If I'm driving, I'm driving. Actually, I'm just sitting in the car. I'm reading my newspaper because my car takes me home. It's the road that it knows and so on. But let's say along the way, someone did something with that intersection, and all of a sudden it doesn't understand. What's the default thing? Does it stop? I mean, I don't know if it's a stop sign or not, but for safety reasons.
Exactly. For safety reasons, it defaults to the driver by slowing down, not by emergency braking, because this is also a concern.
Yeah.
But you're thinking that it sees a stop sign. That stop sign is recognized, I don't know in meters, but maybe a very long distance ahead, and it can already start to notify you. And the default behavior is always revert to the driver. It does not assume or take any decisions on its own. And the same, for example, we have a lot of signs that we're doing this data labeling with frontal camera, but as humans, labelers, sometimes we do not recognize a sign because weather conditions or whatever, it's very far away and so on. There's a lot of situations. So we have this, let's say, excluded category. We do tell the algorithm there's an object there, I don't know what it is, you're not going to train anything on it. You're just going to exclude it, you're not going to assume what it is, and so on. So that's it.
Yeah. Thank you. That's pretty much what I do.
One more question.
Hey, what about autonomous driving in virtual space? Either if it's synthetic or taken from actual data?
We deploy the models in these synthetic environments before testing them in the test track and before testing them in the real world. Also to take them, let's say we have a release version for the software, and to test it out on the streets, you need some government approvals, and they vary by country. So I cannot just go right now with my car and test my latest
I assume that you cannot use data that you currently have from the current machines that are in.
We have special machines, so the ones, I have to scroll back to the slide. I will show you, because it's easier. So the data that we record, it's all proprietary data. And this is what most companies do at this scale. If you're a very small startup company or you're doing a project on your own, you can have a lot of free data sets that you can use. But all large companies record their own data, and they have these special equipped vehicles that drive on predefined areas on various continents and countries. And we have data recorded across the various years. I'm not sure when the first recording started, but so on. And we also need to update the recordings because we're getting better cameras, better sensors. There's a new radar, new LiDAR, come on, and so on. So we're always getting better data, and it doesn't mean we eliminate the old data from the training, but we just add more newer and better data on top.
Thank you. So, we did it. Thank you to all the speakers. Thank you to everybody for coming here. And just wanted to a small mention before I give green light to go to finish everything what we still have here to drink and to eat. It's the thing that we are building a community here. So we invite each one of you to come to us with ideas, to come here to present, because this is what we are doing. We are challenging people with ideas, with subjects which are interesting. So I'm here. Come to me. Also talk to the person who invited you here. You find us also on the Meetup page. And of course, you know who we are, so you can come to us to this place anytime. With this being said, I want also to thank you to the team there on the back who did the filming. Also to thank Andrea. She's not here, for preparing everything, for having all the chairs here and all the benches, and all of you who helped to do that. And yes, and I think the moment came. So this was the end for tonight. go finish whatever you can finish what is there, and see you in the next quarter.
Mm-hmm.
Bye.
Thank you. Am trecut, mă?